Welcome to our exploration of Newton's laws of motion, developed by the brilliant physicist Isaac Newton. These laws form the foundation of classical mechanics and provide insights into the behavior of objects in motion. These laws are not just a theoretical concept, they have a practical applications in our everyday life, from the motion of a vehicle on the road to the dynamic of heavenly bodies in space. Newton's law govern a wide range of phenomena. Understanding these laws allows us to design safer vehicles, predict the trajectories of projectiles, and explore the universe around us.
Let's delve into Newton's first law, often termed as the law of inertia. This principle asserts that an object will persist in its state of rest or uniform motion along the straight path unless compelled to change by an external force. Put simply, objects have a natural tendency to maintain their current state of motion unless an external force intervenes. Moving on to Newton's second law, also known as the law of acceleration. This law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. In other words, the greater the force applied to an object, the greater its acceleration, and the more massive the object, the less it will accelerate for the same force. Now let's explore Newton's third law, the law of action and reaction. This law states that for every action, there's an equal and opposite reaction. When one object exerts a force on another, the second object exerts an equal force in the opposite direction. This principle explains a phenomena such as the propulsion of rockets and the recoil of firearms.
In conclusion, Newton's law of motion provides a framework for understanding the fundamental principles of motion and force. By studying and applying these laws, we gain insights into the behavior of objects in motion and unlock the secrets of the universe. Thank you for joining us on this journey through the world of physics.